So in this video tutorial number 3, we will be looking at the maths introduction behind the linear regression. As you can see here, we have the equation of linear regression here given, where y represents the dependent variable, b0 represents the y-intercept, b1 represents the slope, x represents the independent variable, and e represents the error. So this is the basically we have the equation for the linear regression. I have already explained this equation in the video tutorial number 2. So as you can see here, graph we have. So here, if you want to predict the stock price, so stock price, so stock price is my dependent variable. Here, y represents the dependent variable. So as an independent variable, time is basically my independent variable, and stock price is my dependent variable, because I am going to predict the stock price over that time. So you can see here, these are all my data points. These are all my data points. These are basically all my data points, and this is basically my slope. And here you can see this line is basically my slope. I have written here as well. This line is basically my slope. So you can also say it as best fit line or the regression line. Basically, this is my basically actual points. This is basically my estimated value. We need to basically create a best fit line or the regression line which basically minimizes this error, which minimizes the error between the estimated value and the actual value. We need to create that best fit line which basically minimizes the error between the estimated value and the actual value. We need to create the best fit line which basically minimizes this error. This is basically my actual value and this is my estimated value. So what we need to create the best fit line which basically minimizes this error. And this is my y-intercept. Y-intercept is the value where the best fit line passes through the y-axis. Like here, if for example it is 2 here, so it is basically passing through 2, and this is 1 and this is 0. So this is the value of my y-intercept. So y-intercept is basically here is my 2, as it is crossing the 2 value. So now we will look at how we can create a best fit line, how the mathematical code calculation involved, what are the cost functions. We will now see it. So let us discuss the as linear regression is a statistical model that attempts to show the relationship between two variables with a linear equation. So we can have a positive relation and we can have a negative relation as well. So here as we have a negative relation in this case. So I will explain you what is basically positive relation and the negative relation. So as you can see here, we have in the x-axis speed, basically our independent variable, and distance, which is basically our dependent variable. Here I am writing dp, and for independent variable I will put it as independent variable short form. Okay. So if you want to calculate a distance travel in a fixed duration, so here we have a positive relation. If you want to calculate the distance travel in a fixed duration, so here we have a positive relation. As you can see here, this is basically my y-intercept, and this is basically x represents my independent variable, and represents my positive slope of line. Basically, this is the equation of a straight line. I have previously explained this equation. This is nothing but the same as it. Here we have replaced b1 with m and c with b0. So all the things are same. You don't need to be confused. So here you can see a positive relationship. So if I want to calculate a time or a duration, so over a fixed duration, so if you want to calculate the time over a fixed duration, here you can have a negative relation. Here you can see we have a negative relation. Here we have negative slope of line, and here we have c as c represent the y-intercept and x represent the basically independent variable, and y is basically my dependent variable. So now let us understand the linear regression algorithm. How does it work? How we basically plot our data point and how we get the basically best fit line. So now I will explain it over here. So if we have the data points of x and y, this represents my dependent variable and this represents my independent variable. Okay, this is basically independent variable and this is basically my dependent variable. Now let us first plot a graph of them, and then we will see how we can calculate. So this is the equation we have for the linear regression. It is the same equation for the equation of straight line as well. So now let us first plot a graph. To plot a graph, we need to find to plot a best fit line. We need to find first of all the slope and the value of y-intercept. So to plot the best fit line or the regression line, always remember you need to first find the value of the slope, the value of the y-intercept. Okay, as we know, we have the formula for the slope is, as you can see here, is given as this is the value formula for the slope. As you can see, x minus x mean, y minus y mean, the summation, and x minus x mean squared. So here we can first of all find these are the values of x, these are the values of y. So I found the mean value of x here comes the 3 and the mean value of y is 3.6. You can calculate and recheck it as well. And this I have calculated x minus x mean. These are the values coming. And here it is y minus y mean as well. And here I have, as per the formula, I have to multiply x minus x mean with the y minus y mean. So I have done the multiplication, and here we have to calculate the x minus x squared. So here I have calculated the x minus x squared. So I basically find the mean of these all these values, and it comes as 4. So we can again check 2.8 plus 1.2 is 4, and 0.4 minus 0.4 just cancels out. And here, as you can see here, if I find the mean value 4 plus 4, if I plus some value, some value, it comes out 4 plus 4 plus 2, and it turns out to be 10. So if I calculate the sum value, it comes out to be 10. Here the sum value comes out to be 4. And here I have calculated the mean value of x and the mean value of y to calculate this equation. So if I put these values, all these values, it comes out 4 divided by 10, and it comes out 0.4. Now if I put the value of slope here in this, like here I put it slope value of slope is 0.4. We have mean value of y as 3.6. I have put it here, and mean value of x is 3. I have put it here as well, and have calculated the c value, which turns out to be 2.4. I hope you have understood it. You just need to put the mean value of y here and the slope value of slope here, the mean value of x over here, and so you can calculate the y-intercept c value. So I have got the C value as 2.4, I have got the slope as 0.4. Let us see how we can create a best fit line using these values of slope and y-intercept. So now let us calculate the predicted value of y for the values of x is equal to 1, 2, 3, 4, 5. So if I calculate the predicted value of y for the values of x 1, 2, 3, 4, 5, as I already calculated the slope as 0.4, c as 2.4, and the so to calculate the predicted value of y for the values of x 1, 2, 3, 4, I will just look at x1. I will got the value of 2.8. Here I put the value of x2. I got the value of y 3.2, and here I put the x value of 3. I got the value of y 3.6. Now here I put the x value of x 0.4. I got the value of y, predicted value of y 4, and here I put the value of x 5, and I got the value, predicted value of y as 4.4. Now to plot the best fit line using this equation, if I see here, I got the at x is equal to 1, I got the value of y 2.8. So at x is equal to 1, my value of y is 2.8. At x is equal to 2, my value of y is 3.2. And x is equal to 3, my value of y is 3.6. And x is equal to 4, my value of y is, this is my value of y is 4.0. And x is equal to 5, my value of y is 4.4. So this is basically my best fit line, or you can say regression line. So this is how we can create a best fit line, or you can say a regression line. So our main aim is to create a best fit line which basically minimizes the error between these. These are basically my estimated values. These are my actual values. So our main aim is to create the best fit line which basically minimizes the error between this estimated value and the actual value. We need to minimize this error. So you need to just understand. And how we can calculate the accuracy, how much better our best fit line is we can calculate with the R squared and other parameters. We will look at in the next video section of the. Now to check the accuracy and goodness of fit, we use the R squared value. What R squared value is? R squared value is a statistical measure of how close our data points are to the regression line or the best fit line. So we have the formula for the R square value where y is my predicted value, y dash is my mean value, and y is my actual data points, and this is my y dash is my mean value again. So if my value of R square is equal to 1, it means my data points are lying on the regression line. If the value of R square is equal to 0.9, it means very close to the regression line, and value of R square is equal to 0.02, it means very data points are very far away to the regression line. It means there is a huge amount of error between the actual values and the estimated values. So the more the value close the value of R square is to 1, it means the more our good model is, the more accuracy accuracy wise our model is better. So we just need to remember this. You just need to remember this formula to check the accuracy or goodness of fit through R square value. As R square value tells us how good or accurate. Thank you so much for watching the video. If you like the video, do subscribe the channel. See you all in the next video.